OSPF stands for Open Shortest Path First. IGRP stands for Information Gateway Routing Protocol. The new version of IGRP, we have added E, which stands for Enhanced Information Gateway Routing Protocol. Then there is BGP. BGP stands for Border Gateway Routing Protocol. Then IS stands for Intermediate System to Intermediate System. Okay. So these routing protocols I've mentioned, some of the routing protocols, some of them are interior routing protocols, some are exterior routing protocols. So what it means by interior routing protocol is a protocol that is configured within the same network. It doesn't go beyond the border. Exterior are the one which can be used to, let's say you are connecting two networks, this network and different network. Let's say Bank of Zambia and Bank of China. These are two different networks. And it's a border gateway protocol that can work, BGP, to link these two networks together. Then even the intermediate system to intermediate system, it's an exterior routing protocol. Okay, so within these interior routing protocols I've talked about, some of them are called link state routing protocols. They're called link state routing protocols. Then others are called distance vector routing protocol. Like RIP, it's a distance vector, whereas OSPF, it's a link state. We'll go into detail later. So just know that when you're at the network layer, this is where you do the routing protocols, the IP addressing, subnetting also, this is where you do the subnetting. Then the network layer also defines how to fragment a packet into a smaller packets to accommodate different media. What is to fragment? To fragment is to break down a packet into a small chunk. It's called fragmentation. So it's on the sender side where a packet will be fragmented. Then the other side will defragment, like assembling. So these packets will be assembled together to make it now. These segments actually are called segments. When they are assembled together, they become a packet. Then we have routers. The device that operates at the network layer, it's a router. A switch operates at a data link layer. Examples, we talked about IP, which stands for Internet Protocol, IPX, and APOTOC. Then the data link layer provides access to the networking media. It just provides access to the networking media and physical transmission across the media. The device that operates at the data link layer is a switch. And a switch, it has got a local responsibility, whereas a router has got a global responsibility. For instance, if communication happens within a local area network, let's say Cyber Academy, you send me, we are in Cyber Academy, we are using the network for Cyber Academy. I send you an email. That email, it will just end up. Hello? I can hear you. Hello?
We are with you, sir.
Oh, okay. I was saying, so if in a local area network, when you are sending a message within a local area network, it doesn't even go to the router. Within a switch, so the packet will be sent to the switch. I mean a frame, the switch. And the switch.
Hello? I think someone needs to mute the mic there.
Okay. Someone needs to mute. I thought they were talking to me. Okay. So I was saying, switch has got a local responsibility. So within a LAN, if you send an email, an email will just go to the switch, and the switch will use a MAC address to locate the destination because it's within, okay? Unless if the message or the packet is sent to a different network. This is whereby a switch will look around, find that this address doesn't match with everyone addresses, then the switch uses a broadcast. Actually, what happens is that the switch will broadcast that information. Then whoever broadcasting, meaning that the same message will be sent to all the stations on that line. So if the address matches one of them, they will get the message. If it doesn't match, they will just ignore. Okay. So if the address happens to be the different network, you can tell that this is a different network, this is the same network. For instance, if you know the IP range, it can be 192.168.10.0. You know that anything with 192 is the same network, right? Then if you've got a network like 10.1.whatever, you know that it's a different network, right? So the switch, what it does, it will send it to a router. A router, it has got a responsibility of routing. That's where the name of a router comes from. So it will write, it will route to its destination. It will route to its destination. So the data link provides reliable transit of data across a physical by using a media access control address. The data link layer uses the MAC address to define a hardware or data link address in order for multiple stations to share the same medium and still uniquely identify each other. Okay? So there are two layers within the data link layer. There is a MAC layer and a LLC, logical link control. Logical link control. MAC stands for media access control. MAC stands for media access control. Then the data link is concerned with network topology, network access, error notification, order delivery of frames, and flow control. Flow control, because tracing is also happening at the 2, because it's a local responsibility. Addressing is also happening at the transport layer. That is, if it goes, it's local responsibility now. So, example of this of Ethernet technology. Okay, Ethernet technology. We need to know what an Ethernet technology is, why it's not popular. But technology like frame relay, there are so many technologies. We've got so many technologies at the data link layer. Then the physical layer deals with the physical constraints of the transmission medium. Physical constraints of the transmission medium. It defines the electrical, mechanical, procedural, and functional specification for activating, maintaining, and deactivating the physical. So anything physical, this is where it is found. Then such characteristics as voltage level, timing of voltage, physical data rates, maximum transmission, distance physical connectors, and other similar attributes are defined by the physical layer specifications, specification. So this is what we looked at. We looked at the standard. There was no standard for networks in the early days, and as a result, it was difficult for networks to communicate. They might ask you a question: what is the importance of OIS model? You know, OIS model, it's very important. A long time ago, when you are designing a network, and in the network, you include different devices from different vendors. Communication can't happen. It's more like we are in class. Others are Chinese, others are using English, others are using different languages, and you can't speak same languages. There will be no communication. There will be no communication. You need an interpreter. Is it an interpreter or a translator? Okay, in the networking point of view, you say an interpreter, right?
We get the point.
Yeah. So OIS model works like an interpreter. There's nothing like this device is for Cisco, this device is Huawei, this device is what. as long as this is applied, all the devices will communicate. It was introduced in 1984. So the OIS reference model has a standards which ensure vendors greater capability and interoperability between various types of network technologies. OIS reference model organizes network function into 7 numbers. We talked about 7 layers. Don't forget those 7 layers. Go and practice so that if I just ask you at gunpoint, you have to tell me 7 layers, the way they are, in a proper order. Not telling me, I know you might know all of them, but you are jumbling them. You tell me physical layer, it's there, what, but the question will be layer what? You have to know it.
Yeah, I have a question.
Okay.
That has confused me a little bit. So what is the main difference between a layer 1 switch and a layer 2 switch?
There's no layer 1 switch. There's just a layer 2 switch and a layer 3 switch, which function like a router. A layer 3 switch will function like a router.
That's what I meant.
Okay, a layer 3 switch, it has got function of a router. Okay, have you heard of power over Ethernet switches?
Yes, I have.
They are written as capital letter P, small letter O, then capital letter E, right? POE.
Yes.
Those are power over Ethernet switches. They are layer 3 switches, meaning that when you manage them, they will start working like a router. But if you don't configure them, don't manage them, they will just work like a normal switch at the layer 2.
So if you've got a layer 3 switch, you don't need a router?
No, you don't need a router, you got a layer 3 switch because you just manage it so that it works like a router. Yes.
Okay.
Mm-hmm.
And then also, why is it amongst the protocols, the routing protocols, I hear more of EI, GRP, and OSPF more than the other ones? Is there any particular reason for that?
These ones actually just depend with the organization. Maybe others that are into OSPF. And remember, these are like OSPF, it's a Cisco proprietary. It's for Cisco. So if you are using other technologies, you can't use OSPF as a routing protocol. It's not on the open market. It's a,
okay.
If you hear more of those, meaning that at that particular moment, maybe the devices are for the Cisco. It's a Cisco proprietary. Some of this is just sometimes it's a preference.
Okay.
Play music.
I think just mute all of us.
All right.
From your end.
Let me do that. I mute everyone, huh? Anyway, since we are about to finish, 1 hour is about to elapse, so, and we are just concluding. Just make sure that if there's a noise where you are, just mute yourself. Just mute yourself. Okay. So each layer provides the service to the layer above it, meaning that layer 1, physical layer, will provide the services for layer 2, which is data link layer. Data link layer provides services for network layer. Network layer provides services for transport layer. Transport layer provides services for session. Session provides for presentation. Presentation for application. That's how it is. That's how it is. So only the headers will be included. There is we'll talk about headers as we go on, but make sure it's very important we install the packet tracer. I mean, we install the Riverbed or the OpNet on your machines. Labs will be doing or are done using the packet tracer. We'll see how it will be done. We'll see how it will be done.
So how do we get the Riverbeds?
I'll give you, I have it. So we just have to find time. We link up at school. I install all the devices. Then learning, we can learn remotely as long as we've got the software. We'll be just following the steps, whatever I'm doing. Yeah, because you can't have it if we don't meet physically.
Okay.
Yeah. Okay. All right. So this is where we have ended for our class. I've done a recording, and this recording, I'll upload it on my YouTube channel. Then I'll send you the link on the group so that whoever missed the class, they can follow the tutorial via YouTube. Do you have any questions? Any questions?
No.
No,
So
I'm
the
good.
next class is gonna be Tuesday.
The timetable is saying Monday. I'll share the timetable on the group.
Okay.
I'll share the timetable on the group.
Okay.
Okay, so have a good night.
All right. Thanks a lot.
Good night.
You're welcome.
Thank you.